Minasan, ohayou gozaimasu. So I'm going to talk today about Scala.js, which is the Scala to JavaScript compiler, and specifically a bit of the historical facts that have marked the history of Scala.js up to now, and most importantly, how they shape how we decide what to do with the new language features, and how to shape the future of Scala.js. And I will very specifically talk about what we're going to introduce in 1.0, which is due soon-ish. We'll talk about that. So if you want to pronounce my first name in my original language, in French, that's Sébastien. But if you pronounce it Japanese way, it's fine as well. So, as I said, we're going to talk about the past, which is from the very first commit of Scala.js up to the current version, which is not actually 0.6.15. It's almost there. It was supposed to be released last week, but we're a few days out of schedule. And then we're going to talk about the future from here to 1.0. The past. So this is the very first commit of Scala.js. This is a Scala JVM code that has just a main method that prints hello, and then there was a build SBT file that was 0.12.4 at the time. And it also, so one thing that is fun to notice here is that even this very simple code wouldn't pass our quality or code quality requirements these days, because there is no explicit return type here, and this is a public method, so this is bad. It wouldn't pass CI nowadays. So the very first time I presented Scala.js in a public setting was 4 months later at Scala Days 2013. That was in New York. And at that point, we already had a playable demo of the Reversey game, also known as Othello. And this very specific application is actually still used. It's still in our code base. It's still used as our regression test for the code size that we emit, the size of JavaScript code. And surprisingly, there has been very little changes to the source code of that demo application since then. Which means that we haven't broken so many things in that time, which is interesting. So we had a demo, but a few things were pretty bad at the time. So for example, calling Scala.js from JavaScript was really not nice at all. You had to know about this guy here, and you had to know the encoding into a directory of classes, and then somehow call the JS constructor. And supposedly we were supposed to know all of that. So at the time, this was a big problem. However, the other way around, so calling JavaScript from Scala.js, was surprisingly good at the time. And actually, we haven't changed much since then. So this was the first thing I wanted to get right in Scala.js was interoperability with JavaScript. And I think we did a pretty decent job at it. So here you can see that this is a piece of Scala.js code, and we're actively interoperating with a JavaScript object here, selecting fields, calling methods, doing computations on them, and it's all seamless. You don't really see the boundary between Scala.js code and JavaScript code. And this code is basically unchanged still at this point. And even at the time, this was all based on the concept of facade type, which is you define in Scala code types for the JavaScript API that you're going to call, because, as you know, JavaScript is dynamically typed. And basically, you extend this js.object or js.any marker type, and then the Scala.js knows that this is a facade. It's not actual Scala code. It's just so that it has types to talk to JavaScript. Okay, so moving a bit faster now. So in November 2013, we had version 0.1, so that was like 8 months-ish after the inception of Scala.js. And at this point, we had mostly correct code generation. So the language part, the Scala part of Scala.js was pretty much complete at this point. We integrated with the Google Closure compiler to minify the code, because before that it was like 20 megabytes of JavaScript for Hello World. And we had integration with SBT, with incremental compilation, also with IDEs, and all of that. Basically, we had a lot of tooling that was set up so that you could actually use this thing. And we had tests, which were contributed by Jonas Fonseca. We didn't do them. So we just wrote the compiler, and then someday we had a PR. Hey, here are tests for you, compiler. Oh, yeah, thanks. that's nice. But since the inception, we actually made calling Scala.js from JavaScript worse. So now you need to know the encoding that the Scala.js compiler uses with this underscore, and that was even worse. But we fixed that later. Okay, so in VO2, so in VO1 it was tested. In VO2 it became testable in the sense that applications written in Scala.js, you could write unit tests for them. And that was because some other guy, E.E. Collar, contributed a Jasmine-based testing framework. Jasmine is a famous JavaScript testing framework. So you can see a trend here. We don't do tests. Other people do them for us. At the time, it was true. Nowadays, it's not true anymore. We actually have a pretty comprehensive test suite. And we added JS this function, which I'm showing right here. So when I presented Scala.js 01 at Scala Exchange 2013, one of the questions was, if my JavaScript library expects me to give it a callback that uses the this keyword, what am I going to do? And that was a very good question, because you could not at the time. It was literally impossible. So you could simply not call a jQuery method that expected you to use the this keyword. So this is really annoying, right? If there is libraries there are libraries that you cannot call, that's a serious gap in interoperability. So we fixed this specific example with JS this functions, which map the this keyword. So this is the JavaScript code, which map the this keyword of the lambda into an explicit parameter of a Scala lambda. Because actually, if you think about how JavaScript handles this, it's actually a parameter. So we just make it explicit in the Scala syntax. Okay, so then in 03, that's when we had we managed to compile and test the entire part-test suite. So this is the unit test of the Scala compiler, the Scala JVM compiler, and we started compiling and testing them with Scala.js. So at this point, we were really confident about the correctness of the Scala parts. And we added support for all the JavaScript operators. So the same as before, we could not use the this keyword somehow. Here we extended the support for JavaScript interop by being able to use all the JavaScript operators. A Scala method that represents such operators. So for example, type of, delete, and we even added support for the debugger keyword, simply because there is no other way to do this. So if we don't give it to you and you want to use it, we have to answer, oh, sorry, it's not possible. At least, so this became a very important criterion in Scala.js that we're still applying today, that everything that you can do in JavaScript, you can also do in Scala.js. And that we do because otherwise there are potentially libraries that you cannot call. If they demand that you do some specific thing that JavaScript can do and Scala.js cannot do it, well, you're stuck. So we don't do that. Okay. Yeah. So here in V04, I think the most important thing is that finally we had some reasonable way to call Scala.js from JavaScript using the @JS export annotation, and simply by saying this thing, I want JavaScript to be able to call it, and then you could call it in a normal way that looked like JavaScript, not look like some weird compiler encoding. And we started caring about binary compatibility, which at the time was JavaScript source code compatibility. But so according to Semver, 040 should have been named 100, and that was in March 2014. So apparently, 3 years later, we're only about to release 10, but Semver told us, you should have been 10 for 3 years. So this is how it looked with the exports. Now we finally have some reasonable way to create this reverse class and call it, and that's because we use the @JS export annotations. The next version brought a very important other revolution to the Scala.js world. It was 05. And I like to summarize the changes with this sentence, which is we fundamentally changed from being a compiler to being a language. So what does that mean? It means that if you're a compiler, it's the compiler hacker who is writing its compiler, having fun writing the compiler, and whatever comes out of the compiler is what the language means, and that's how it behaves. And if you're not happy with that and you think there are inconsistencies in some places, well, you have to deal with it. It's the way the compiler works. Whereas being a language first is you have a specification, you design your language, and then you do whatever it takes to implement it in the compiler so that it works the way you intended it to, rather than deciding what it's supposed to do after the fact. So one example is previously, if you define a facade to JavaScript and you call a method foo that expects a number, a JavaScript number, and it was an integer, you could use int here, and that was fine. But if you call a JavaScript method that expects an array of number, and you try to use JS array of int, and suddenly it breaks. And I mean, from a language point of view, there is no reason whatsoever that this should happen. From a compiler point of view, it was obvious at the time. This guy here, the int is in a monomorphic context, so the compiler knows about it after erasure and knows that it's supposed to be a number. But here, it's been erased to being basically a Java long integer, and it's a boxed, it's an object, and JavaScript doesn't understand it anymore. So that was not good. So the right way to do that was to use a JS number instead, which was super ugly. And but it worked because that one was always a primitive number. It survived erasure somehow. But in 05 we fixed this. You can use int everywhere. So this is the difference. And this took significant effort of implementation in the compiler with respect to the previous version, which was we wrote the compiler code and then it worked that way. Here we decided it has to always work. Int has to always be a number, and then you, compiler hacker, which means me, do whatever it takes so that it actually happens. So we did that. I will quickly go over this one. It's not super important. So another example is you're probably very familiar with the map, and maybe not, but maybe the exists method of the Scala collections. And you would expect these two calls to use the Scala map and the Scala exists. But it turns out that previous to 05, the first one was actually called the JavaScript map, which does not do the same as the Scala map. It has obscure, weird semantics because it's JavaScript. And so it was not consistent in the way you used a JavaScript array as a Scala collection. It would not do the right thing. So again, we fixed that by saying it always has to be the Scala semantics for collection methods. And so now if you call map, it's actually a Scala map. And it turns out that it's more efficient than the primitive JavaScript map, because that one we can inline and transform into a loop. So the big leap, we became production ready in 0.6.0. We announced that. It was pretty popular on Hacker News. Made the front page for a few hours. And so what changed was basically that we made a significant promise of stability and backwards compatibility of the language. We basically said the code that you write today, it will work the same in 1.0. And at the time, 0.6.0, we meant it to be basically an RC, a release candidate for the 1.0 version. So we expected 1.0 to be released like 4 or 5 months after 0.6. And well, look at it, we're now more than 2 years in the 0.6x cycle. And this is actually a good thing in hindsight. It does not look like it is, but it is, in the sense that we've managed to add so many new features that are relevant without ever breaking even binary compatibility. So for more than 2 years, we've been able to maintain binary and source compatibility while adding significant features that initially I thought would be released for Scala.js 2, whatever that was supposed to come out. But we're closing in on 1.0 anyway, because there are a few things we want to break, actually. Yeah, this is not that important, except the fact that with 0.6.0 we have a really good story for cross-compiling. So a bunch of famous Scala libraries, starting with Scala.z in a separate repo, but also Shapeless, and then the whole of the core Scala libraries started to actually cross-compile in the main repo and publish artifacts. And that was a big boom, of course, because now you could actually write cross-compiling code using those libraries. Jumping directly to the big revelation, that was 0.6.5 when we invented Scala.js defined JS classes. I was saying there were features I thought that would arrive in Scala.js 2. Well, this is one of them. I mean, this is the one. So people kept asking, how am I supposed to extend a JavaScript class from Scala.js? And I was like, you create a JS function, and then you get this prototype field, and then you put things in the prototype. And so you're basically writing JavaScript, but in Scala, to define a stupid class that extends JavaScript class. So for Scala class, of course, you could use a class keyword and everything. But if you wanted to extend a JavaScript class, this was the only way you could do it. And it was actually hard, because there are hard interactions between overriding and overloading. It's kind of technical, but the thing is, I really thought that this would be like for a major rewrite, or a major rethinking of Scala.js. And it turned out to be, in a sense, a rethinking, in the way that I changed the way I think about JS-any and the JavaScript hierarchy. But technically, we managed to do it in a source and binary compatible way, which was kind of amazing. And we also added the union type A or B, which, as you may know, is coming in Dotty for the JVM, but for Scala.js, we've had it since like 1.5 years already. It's not as good as Dotty's true union type, though, but it does the job. So just an example of a Scala.js defined JS class. So this one extends JS object, but because of this annotation, it says this is not a facade. This is actually implemented in Scala.js. In 1.0, you're not going to need this annotation anymore. It will be by default. And to have a facade, you need a JS native. So here you see that there is an actual body here. It's not written JS native or being abstract or something. And another thing that was interesting with that is that you could relatively easily write object literals to be passed to JavaScript things. So you could define a trait, position, which says I need an X and a Y, and then you could use the new object syntax from Scala.js to create a JavaScript options object like this. But this is something that people had been requesting also since day one, basically, and I was always saying, no, this is never going to work because it doesn't fit in the semantics, and eventually we managed to make it work. Okay, so this is the part where we come to the future, but the future started 5 months ago. So since September, we've really been racing towards 1.0 and take all the important things that we were still missing and really get down to make them really work. So here are a few things. In 06.13, we finally had support for CommonJS modules. So this is really important because the JavaScript ecosystem is really morphing at the moment. It's literally changing from being browser-based development first, in the sense that you have scripts and you have minifiers that concatenate files a bit easy, into using the npm repository of Node.js libraries and even publishing browser libraries as npm things, and then using linkers of sorts, things that are able to do tree shaking, to combine the libraries that you use and minify them, etc. And you could not really leverage that ecosystem from Scala.js before, simply because Scala.js was always emitting a script in the browser tradition. And so now that we have added CommonJS module support, which is like Node.js modules, now you can actually leverage much more the JavaScript ecosystem as a tooling environment, just as much as a language. So now we have interoperability with JavaScript, the language, which we had for a long time, but also with the JavaScript ecosystem, with their build tools, their minifiers, their linkers, and things like that. So this is just an example of how you make an import of another module. So if you're writing ECMAScript 6 code, you use this syntax. If you write a CommonJS module, it's this syntax, but it basically means the same. And in Scala.js, what you do is you define types for the bar module, and you say, actually, this object bar, I import it from bar.js, and I import the complete namespace. So this is the star. The star is the namespace. And then you define a function, and then you can call it. We also, so in 06.14, we added support for so-called configuration objects and export top-level functions. So the top-level functions, it's simple. Before that, we had to, if you used exports from JavaScript, you would have to call it like this. So my app and parentheses to actually lazily create the instance of this thing and then call the main method. But now we can export a method to the top level, and then it's simply a top-level function for JavaScript. And configuration objects, I don't have time, it's fine. So remember the position from before with an X and a Y, and that you instantiate afterwards, and you create a JavaScript literal object. This is fine if you have 1, 2, 3 fields that are basically mandatory and you have to specify them all the time. But if you have a so-called configuration object like JavaScript libraries like to have, it's like a huge object with zillions of fields, like 10, 20, 50, that have default values, and you just specify, you override the defaults with fields of the object. if you had to do that before, it was pretty impossible in a type-safe way, because every time you create such an object, you would have to fill in all the fields, including the ones that have a default value that you don't want to override. So this was not good enough. So now you can actually do this. So in a trait that extends JS object, you can put equal JS undefined, and it has to be exactly undefined. And then when you create them, you can only override the fields that you care about and leave out the other ones. And this will still create just an object that just has an X field. It won't actually create a Y field with the undefined value. So it's really complex in JavaScript. This is just the mutable version of the same code, where you use vars, mutable variables here. And then it's a bit easier on the use side, but it's mutable. So depending on if you avert to mutability, you might prefer the previous one. But it seems like the Scala.js community, I was advocating the immutable version, but then most of the Scala.js community said, actually, it seems like the mutable variant is better, because it's just easier to write. And that's what matters eventually. So yeah, there was supposed to be a precise date here, but well, it will be in the next 1 or 2 weeks after I come back from Japan into Switzerland. And so the things that are coming in this version, it's basically the last 0.6 version. So this is a big moment for us. After this version, we're going to branch off for 1.0. We'll remove the deprecated things and things like that. And so it means that in this version, we're packing all the things that we never did before and that we had to do. And that includes a few major features that have been requested by the community. So let me go over the things that are coming to you like in 2 weeks or something. So first, exporting top-level variables. So remember that export top-level from before, you could export top-level functions, but really only functions, because a function, it only does something when you call it first. So that was easy to implement. But now you can export top-level fields, vals or vars. And that means that if you do this, the object my app is going to be created eagerly when you load the JavaScript produced by Scala.js. The object is going to be instantiated because we need to initialize that field right away, and then you can use it from JavaScript just as a top-level field. Actually, I don't really have a slide for this, but we're also adding, you can also now annotate the object with add.js export top level, and that means you can get the object without the parentheses. Remember, we had my main, and then we had to call it because it was a function that lazily created the object. Well, in the same way that now, anyway, we need to be able to create objects eagerly for fields, we can also annotate the object, and then it's just my app dot something. Static fields and methods. So sometimes JavaScript libraries like React, they want you to give them a class that you defined, a JavaScript class that you defined, and that has static members, like static fields and static methods. And in Scala.js, currently in 0.6.14, you cannot really define static fields in a JavaScript class. So this is a limitation according to our big master plan, which is that we're supposed to be able to do everything that JavaScript can do, right? Remember that from the beginning? And so this has been something that the community wanted very badly. And it wasn't, yeah, it required some thinking, so that's why it took a long time to get there, to get this to work with reasonable semantics, but now we nailed it. And so we implemented that. And so now you can export top-level, fields as static members of the companion class, basically, and same for methods. So this Scala.js code, it behaves the same as if you wrote this JavaScript code. So there is a class foo here, and it extends JavaScript objects, and it has a static method bar, which is this guy, and it has a static field x, but there is no declarative syntax in JavaScript to create a static field yet. So instead, that's how you define it, but it's really a static field. So now you can do that in 0615. And another one that took a really long time to get right, and that is coming, is, it's been merged now a few days ago. So this is support for ECMAScript symbols. So until ECMAScript 5.1, which is the one version of JavaScript that most people target at the moment because it was supported, all fields and all methods in JavaScript have a name, which is a string, right? Even in an array, the indices, which you might think are integers, they're actually strings from a spec point of view. But now in ECMAScript 6, fields and methods, they can have a symbol name. A symbol is similar to a Scala.symbol. So it has a unique identity that is shared globally. And it's not a string. It's a symbol. And you can also create unique symbols that are unforgeable. So with that, you can, for example, implement private methods and private fields in JavaScript, which you could not do before. Now you can really create symbols. But the trick is, to create the symbol that is the name of the methods, you need to execute some code. You invoke the symbol constructor. And this is weird, because now if I want to define an iterator method, from JavaScript's point of view, its name is supposed to be the symbol.iterator. And that means you need to execute some codes at the time you're defining the class. That's a bit weird. So it took some effort to get this right. But now you can do it. So you can specify here not only a constant string, but also a reference to a symbol, a JavaScript symbol, and it will translate in a way to this JavaScript code where we have here a computed name for the method name, which is reading the symbol iterator thing. So yeah, this is basically actually already the future. The future is almost there. For 1.0, and I'll have to be quick. So basically, I have shown you everything that will be in 1.0 already, almost. 1.0 is more about removing things than adding new things, because we've managed to add everything we wanted in a binary compatible way anyway. So now we're going to get rid of all the obsolete stuff. And this is a bunch of things that we remove. I won't go over all of them, but things that are important are, I guess, this one that was basically unused and didn't fit in the semantics. This one turned out to be, so this one we're not removing actually, because the community said no, we actually need those, so don't remove them, please. So we're not removing them. Okay, let's keep this. So we're removing a bunch of things, but most importantly, we're also moving to separate SBT plugins. A bunch of features that are used kind of work, but we're not super happy with them, and we're not really happy with keeping them in the core that we're really support for years to come. So JS dependencies is one, the Phantom JS runner, we can decouple those things and put them in separate SBT plugins so that they can evolve at their own pace. And skip internal changes. It's not that important. There are a few language enhancements. The one thing I mentioned before, you don't need this anymore. But most importantly, this example, which unfortunately I'll have to rush through, but it's mostly the fact that now you can actually create new classes at runtime, new JavaScript classes. Right now, if you write this code, it translates to this, which is super bad because the X here, which is supposed to be a capture, it leaks as a parameter, and then it's basically unusable from JavaScript. So in the next version, we're going to fix this, but it's technical. I'll skip this one. It's a JavaScript peculiarity. Yeah, so the migration policy for 1.0 will be language-wise, everything that works without warnings in 0.6.15 continues to work. Build-wise, you might need to add additional SBT plugins because we've moved things away. But unless you use Rhino, everything will still work. OK, so when? Well, 2017, almost there. Really, a couple months, I promise. That's it. Thanks. I'm not sure we have time for questions. It says last 1 minute here. But yeah, anyway, thank you.
どうもありがとうございました。Thank you for a nice presentation. 会場の中でどなたかご質問のある方おられますか Does anyone have a question?
Yeah, you've already addressed Scala 1 or JS 1.1, but I'm sort of thinking beyond that now. I hope you guys are as well a little bit. Are you planning on supporting some new language features that are coming out in Dotty beyond union types anytime soon?
Things coming from Dotty. Yeah, sure. So actually, Scala.js, it's built on the official Scala compiler. So it's not like we're re-implementing the Scala compiler. So supporting Dotty, it's mostly a matter of porting the Scala.js compiler plugin so that it works with Dotty. And then all the Dotty features will also apply to Scala.js, right? It will be Dotty.js in a sense. So, and the part that needs to be ported is really tiny compared to the immensity of the Scala.js code base, which is 120K lines of code at the moment. The part that needs to be ported, it's only 5K, 5,000 lines of code. That's ridiculous. So yes, eventually we'll get around to port that part, and then you can use Dotty.js, and you will have all the features of Dotty with all the features of Scala.js.
How important or difficult is it to bootstrap Scala C compiler in Scala.js?
It's so language-wise, right? We support the entire Scala language basically. So that part is okay. We can compile the Scala C compiler with Scala.js. The problem is it uses Java libraries. It uses Java libraries to read files. How do you do that in JavaScript? Well, it also uses Java libraries to read bytecode and write bytecode, JVM bytecode. And actually, we need to do these kind of things, even in Scala.js for interop with other things. And in general, the code was written in a way that kind of assumes some JVM libraries are there. And so it's more a matter of avoiding or modularizing the use of Java libraries from Scala C, so that we can really compile it with Scala.js. And we've done some work on it. We managed to have the type checker and auto-completion work in Scala.js, but it requires significant engineering efforts that we don't really have in the core team. Yeah, yeah, we want to show them that with Clojure that we can do it too, indeed. Okay, thank you very much. ありがとうございます。
どうもありがとうございました。明日